Okay, this first one, we need 2, 3, 4, 5 carbons, and then an NH3, 2, NH2. Is that okay? Is there another name we could give this? Okay, so what do I need for the next one? Six. So 6 carbons, and then what?
Nitrogen. And 2 more carbons on top of that.
Is that it? Mm-hmm. It's an amide, right? Not an amine. So what do I need? And where would that be? On the right. So one of the major differences between being able to name the amines and the amides is this piece here that has the carbonyl group on it is the root name, regardless of how long it is. Does that make sense? So what if the molecule looked like this? 2, 3, 4, 5, 6, nitrogen, H. What's the name of that thing?
Hexane, ethylamide,
So
hexylphenone.
what is that? That's an amide, right? Okay, so that is my amide name. So instead of it being hexane, it's what? Are we okay with that? So the thing that's really long, the carbon chain that's really long, doesn't get the name because it doesn't include the functional group. The longest carbon chain isn't part of the functional group. The reference to the longest carbon chain is the longest carbon chain that includes the functional group that we're naming it for, and the longest carbon chain with the functional group is only 2 carbons long. And so then that real, very long carbon chain, which is 6, actually is just going to be counted as a side chain to name it. Does that make sense? Heptanamine. Okay, so 2, 3, 4, 5, 6, 7, and it's an amine. So 4-chloral. 1, 2, 3, 4. I'm going to put a chlorine right there, and so then I got a nitrogen right here, and I've got a methyl group coming off the nitrogen, and I've got a sec-butyl coming off the nitrogen. We good with that? Hate that. And then the last one's pretty simple. 2, 3, 4, 5, 6, and 2 NH2. How's the last one named? What's the type of nomenclature? The first three are all chem abstract. And this one's what? Yeah, the normal IUPAC method. All right, let's do this. So this one here is primary. This one here is secondary. This one here is tertiary, and this one here is primary. And what's the importance of that?
Determine reactivity.
Yeah, it lets you know how reactive the thing is. So of the amines that I have up here, which is the least reactive?
The tertiary.
That giant one, right? There's a lot of stuff in the way to get access to those lone pairs of electrons that are on the nitrogen. All right. So we want to name this one. Okay, so how do you want to name the first one? Propanamide? Okay. And this guy's primary. And the next one? That work? The next one? That work? Don't get confused about that line that comes off the bottom of the nitrogen. Because on the prior problems that meant a methyl group, but since all the atoms are identified, if you have all atoms are identified one, then all the lines just mean bonds instead of actual like methyl groups or something. And the last one, I think the easiest way to name this one would be 1,4-diaminobutane. And it's primary. All right. What did I need to complete this? Where's the break point on this molecule? Where do I cut it in half? Yeah, right here. Those two pieces didn't used to be connected to each other. So the piece on the right was just write CH3NH2. I'll write it the way we have it up there. And then over here, that good? So what's not shown? Yeah. What kind of reaction is this? It's just an acid-base reaction. The nitrogen's lone pairs of electrons are acting like a base. Okay. And how about this next one? What do we need for this? little ambiguous. So as long as you're looking at the molecule and find the carbon-nitrogen bond and just bust it in half, you just put an OH on the carbonyl side and an H on the nitrogen side, and that's the end of it. That's how the amides are made. And why are the amines basic? That good?